device, so we do have a better nasolabial angle and better aesthetics of the lip support. So I scan these models with my desktop scanner, and then I converted the actual stone cast into the virtual working cast. So we just do the digital workflow. We plan to make immediate denture that will be delivered right after the extraction. So I basically use my 3D printer when I make the denture. So I print the tooth part, I print the base part, and I bond it with the resin cement. So this is the final design of the immediate denture before the extraction. And I made immediate denture. And at the day of extraction, I delivered my immediate denture. And after the healing of extraction sockets, I made another set of impression, very conventional final impression, and I made a wax ring. So I put the wax ring in the patient's mouth. I saw the occlusal plane, I followed Alla-Travis line, and I also checked the interpupillary line. The interesting thing that I did into this wax ring is I put a T marker. T marker is I made a capital T with a radio opaque flow over resin. The reason why I did this was to make this as a reference point when we merge desktop scan data with the facial scan data. So the patient got a facial scan with the wax ring. You can see the T markers here. And we did the desktop scan of the recording base, and we also have a T marker. So we use these T markers as a reference point. And because we use T markers, the merging process was very accurate. So from here, we could arrange our new set of teeth. And I made a new set of denture for the patient. So basically I made two sets of dentures. The first one was immediate denture. The second one was after the healing, the new denture. And then we moved on with our implants. So I duplicated the existing denture, the one that I made recently. And then I put another T marker into the duplicating denture. And because the patient was edentulous, as I said, we do the double scan. The first scan is the scan of the radiographic guide only, so we do have this data with a T marker. And the second scan is we put the radiographic stent in the patient mouth and we take CBCT. And because this T marker is radio opaque, we can see it from the CT. So because we have these two CT data, we can merge these two with the reference point T marker. So in the software, we planned our implants, 4 implants, and all on 4 concepts. So we made a good impression of the maxillary denture, and for the lower, we connected scan body and we took the impression. We scanned the impression with desktop scanner, and now we do have a virtual working cast. And in this data, we do have information with the soft tissue. We do have the information about outer surfaces of the denture and also the interocclusal record. And we can do the 3D data modification so that we can move on with our final definitive zirconia prosthesis. So with the help of the facial scan, we did the facial scan again, and we merged this data together, and we're designing our new zirconia prosthesis. So maxillary complete denture and mandibular full fixed zirconia prosthesis were made and delivered to the patient. Okay, as you can see from the picture, the prostheses are in harmony with the facial aesthetics. This is before treatment, this is after treatment. So basically, I used my desktop scan data and I did the facial scan and I combined these two. But now I'm trying to incorporate CBCT into this whole digital workflow. So here's a desktop scan, this is CT scan, and the facial scan. So the CBCT, we use it for the diagnosis of the bone, but also in the treatment, we can utilize our CBCT that we can get more information. The reason why I'm incorporating CBCT into the desktop scan is I want to eliminate the use of the facial scan. The facial scanner is a great tool for sure, but the problem is we have to buy a facial scanner. If you have the facial scanner already, you can just use it without any problem, but if you don't have your facial scanner in your clinic, you have to buy a new one. And another problem with the facial scanner is that it has its own errors and distortions. The distortion of the facial scanner is inevitable because it goes around the face. And there's an error where the curve is. The facial has curves, especially in the canine area and the corner of the lip area. So in this facial scan, the error occurred here, and it's not very important because we do have accurate scan of the mouth. But if this error had occurred in this part, that's going to cause a lot of distortion and trouble. So now I'm trying to eliminate this facial scan from my digital workflow. So with a very advanced